This video will show how to use the diffraction wizard for 3D ray models in OMNI. Here I have loaded a 3D ray model which consists of 4 horizons including the topography. To access the wizard, I'll right click on the model, go to Rays, and choose Diffraction. OMNI will quickly calculate some derivatives and then present me with a wizard. This wizard allows me to choose a diffraction location in the map view, either using the mouse or by entering the easting and northing of the diffraction in these edit boxes. So I will select a point. The depth of the diffraction can either be on one of the subsurface horizons, in this case I've chosen the yellow horizon or the lowest horizon, or I can enter the elevation manually. If this is checked, that means that the diffraction will be taken as normal to the surface. So it will take the dip in the azimuth of the surface into account. If this is not checked, then the diffraction will be just a pure diffraction relative to the zero direction being straight up from that diffraction. I'll click Apply to calculate the diffraction, and it's going to calculate diffraction rays out to a maximum takeoff angle of 70 degrees or a maximum offset of 2000. And so here I can see the diffraction on the top of the model, and what I'm looking at is the takeoff angle of those rays. So this is the origin of the diffraction on the yellow surface, and this is the zero takeoff angle from that surface measured relative to the local dip of that horizon. So you'll see that the zero takeoff angle or zero offset is off to the side of the model here. Other things we can look at are the emerging angle. We can look at the emerging azimuth. So these are the statistics of the rays as they emerge at the topography. We can look at the takeoff angle and azimuth. So we can compare the azimuths of the ray as it is created and as it emerges from the surface. We can look at the offset of these rays. This is relative to the zero offset. We can look at the amplitude of the rays on the surface. And we can also look at the time of each ray from that diffraction point to the surface. We can also see all this information shown in the wizard as we move the mouse around. You'll notice that this information over here changes, showing all the statistics for those rays as they terminate at the surface. We can also see the same information in the 3D view. And so here we're looking at the surface time for those rays off of that yellow horizon. Or we could look at the offset, for instance. And then, of course, we can look at various points in the model and compare the different effects. So there's a diffraction over on this side of the model. And that's essentially it.